This is the June 2010 Algebra pilot paper for use of maths. Question number 1. The mass, x kilograms, of each of the 10 cars is shown on the data sheet with the car's average fuel consumption, y miles per gallon. A graph of the data is shown opposite. A line of best fit is given by the equation y equals 65.2 minus 0.0199x. And part A of the question, on the graph opposite, draw the line y equals 65.2 minus 0.0199x. So we need to go to the table function of the calculator, which we do by going to mode and then table. Type in the f of x, which is 65.2 minus 0.0199. Alpha, close bracket to get an x, press equals. Now to start, we'll need to look at the axes and identify on the x-axis where we're starting from, which is 0, and where we're going to, which is 3,000. So 0 to 3,000, and it's going up in steps of 500. So that's what we'll enter into the calculator. Start at 0, end at 3,000. Step of 500. Okay, and so then we get our table. And it's a good idea to copy down the table onto the sheet. So we'll do that. X and then Y. So X is going from 0 up to 3,000. And then the y values we copy from the table, which is the right-hand column. And make sure you use the scroll down button on the calculator to get the other values. And just one more, 5.5. Okay, now we need to plot each of those values onto the axes. And we've got to remember that we've got to be accurate to within 1/2 of a square on the plotting. So the first point is 0.65.2. So 0.65.2 takes us to, right, so to get the scale right, you need 61, 62, 63, 64, 65. Now I can't do 0.2 on there, so I'm just going to leave it as 65, which is there. Next point, 55.25. So that's at 500. So go up here from 500 up to 55.25. So 50 again, 51, 52, 53, 54, 55. Takes us to that point there. And the next point, 1045.3. And so on till we've plotted all of the points. Okay, now we need to join those up with a straight line, and we have to remember that in order to get the marks, the line has to be perfectly straight and not have any double lines, any section where it's double lined or anything like that. Make sure you use a nice sharp pencil. So I'm going to use the straight line function. And make sure your line is exactly going through all of your points, like so. Okay, and we're done. We've answered the first question. Right, the next question, part B, is as following. What is the gradient of this line? And there's two ways we can get the gradient. There's an easy way, and then there's a harder way. So I'm going to go for the easy way, which is just to look at the equation. Now, if you remember, the equation of a line is of the form y equals mx plus c. And the m is the gradient. And that's the number that's in front of the x, which means the gradient is this number here, minus 0.0199. So I can just write that down as the answer. The alternative is to draw a little triangle onto the graph, like so, and then to work out the rise and the run and divide, but that will be more time consuming. So I'm just going to write down the answer, which was minus 0.0199. Part C, use the line to predict the average fuel consumption of a car of mass 1450 kilograms. Okay, so I'll go back to my graph. And I want to look at 1,450 kilograms. So I need to look along the bottom here, decide what it goes up in. So I think this will go up in 50s here. So that's 1,100, 200, 300, 450. So therefore I need to go up this column, up to the line, and then across. And I'm getting there to 36. So I think the answer there would be 36. So I'll write that down here. Okay, and the final part of this question says, cars that have a small mass can have an average fuel consumption of over 70 miles per gallon. Why is the above line of best fit not appropriate for these cars? Okay, well, let's look back at the line of best fit. And we notice that the line of best fit never actually gets to 70 on the y-axis, okay? It stops before that, which means that if we wanted to get 70, to get a y value of 70, we'd have to have a negative x value. And you can't have a negative mass, so therefore that would be impossible. So this line of best fit doesn't apply to that. So we just need to write that down in words. So there's one mark available, so you only really need to say one thing here. So you could say, for example, the maximum fuel consumption for the model is 65.2, because that's where it goes up to, even when the mass is 0, the fuel consumption does not reach 70 mpg.